All right, thanks for watching. We're going to do parallel and perpendicular lesson number 7. That would be the last lesson of this particular unit. And if you saw number 6, or if you worked through number 6, you know that more or less, lesson 6 was all algebra. It was a lesson that I took directly out of an Algebra 1 class or an Algebra 2 class because you can't do this lesson without it. So we're going to do one review question, and then we're going to jump in. Find the equation of the line passing through the points 2, 10, and 5, -2. Now, if you want to know the equation of a line that passes through 2 points, you've got to start with knowing what the slope is. Now, you know that I don't do slope the normal way if you've been paying attention to previous lessons. I just count, and then I do rise over run. So I think about a number line. If you were to go from +10 to -2 on a number line, you went down by 12 spaces. And if you went from 2 to 5, you went up by 3. Slope is rise over run. It's your change in y divided by your change in x. So that would be -12 divided by +3, which would be -4. Now, the reason we need to know that is because now we can write an equation. We can actually say y minus y1, it goes back to point slope form, equals m times the quantity x minus x1. All right. Now, the way I do it, I mean, slope is the first thing. That's not something I do. That's something everybody does. The thing that I do that might be different for some people is I always use the first point. That way, nobody ever has to wonder, where did I get that number from? So I'm going to use the point 2, 10. From here, technically that is an equation. But when I teach, I work toward getting my kids comfortable with slope-intercept form as well. So I make them go the extra mile and actually solve for y. So that would mean if I wanted to get it into slope-intercept form, what I would have to do, I would have to distribute the -4, and then I would have to add 10 to both sides, which would give me a final answer that would look something like this. You would have y equals -4x plus 18. Now, when we start getting into parallel and perpendicular, this is where we have to read the question carefully. Find the equation of a line parallel to y equals 3x minus 2 that contains the point 12, -5. So first of all, I want you to look at the slope number of the old line. I refer to it as the old line. It's the line they give you. In this case, 3. Now, I bring that up because that's what we're going to need to know in order to make our decision about what we're going to do with the rest of the problem. It said parallel. We want a new parallel line. And the one thing we know about parallel lines is that the slope of parallel lines should be the same, which means I can take that 3 and I can just drop it right in. Now, from there, they gave you what point to use, so you might as well just use it. Okay, they gave you a 12 to put here. They gave you a -5 to put here. Oh, no, 2 negatives. Oh, well, just make it positive. Just make it positive. And from there, the question looks exactly like the other ones, where we distribute and then we subtract. So if you distribute, 3 times x is 3x. 3 times -12 is -36. And last but not least, you've got to subtract the 5 from both sides in order to get your final answer. Here, let me get rid of that circle. That was not very pretty. We got y equals 3x minus 41. There you go. Now, the difference between a parallel and a perpendicular situation is that parallel lines have the same slope. So you keep the slope number the same. If it is a perpendicular situation, you do not want to keep the slope number the same. You want to use some of the tricks that we've talked about. The most common teacher term when we begin to talk about perpendicular slopes, you hear a lot of teachers refer to opposite reciprocals. And essentially that means you change the sign and you flip the fraction. Which means if the slope was originally 3 and this time we want a new perpendicular line to it, now we have to flip the 3 into a 1/3 and we have to change it from a positive to a negative. So your new slope is going to be negative 1/3, and that's the one you're going to plug in. So again, this is a step that you have to do when we are talking about perpendicular. It is not a step that you have to do when we are talking about parallel. Now I use the same other information. Oh no, 2 negatives. There you go. I used the same other information just so you could get in the groove here. Now, the same last 2 steps are going to apply. Negative 1/3 times x is negative 1/3 x. A negative times a negative is a positive. 1/3 of 12 is 4. And then last but not least, you have to subtract the 5 to finish the deal. So when you get all of that done, you should get y equals negative 1/3 x minus 1. All right, pause that if you need to. If not, that's okay. We're going to keep on moving here. Find the equation of the line parallel. All right, parallel means same slope. That means I don't have to do anything to the slope that they gave us. I can keep it exactly the same, and I can just plug it in the way it already appears. That means I'm going to take the slope, and it's going to be 1/2, and I'm just going to plug it in. The point that they gave us is -6. Oh no, 2 negatives. All right, change that to a positive. And 4. The same 2 steps that we were doing, we're going to do again. Hopefully by now you can kind of see why we did lesson number 6. So lesson number 7 would just feel a lot easier. 1/2 of 6 is 3. Last but not least, you need to add 4 to both sides. You should end up getting y equals 1/2 x plus 7. Checks out to me. Hopefully it checks out to you. When we get to perpendicular for this problem, we have an extra step to do. Hopefully we kind of pick up on why that's going on here. If it says perpendicular, you don't want the line that you create to have the same slope as the old one did. You need to change it. So 1/2, you need to flip the 1/2. You need to change the sign. So now instead of positive 1/2, it's going to be -2/1, which I am just going to call -2. I'm still going to plug in the x value next to the letter x. Oh no, 2 negatives. And I am still going to plug in the y value next to the letter y. From there, we're going to distribute. -2 times x is -2x. -2 times 6 is -12. And then last but not least, make sure you add 4. When you add the 4 to both sides, you should get, and I'm kind of running out of room here, but I think we can probably manage, y equals negative. Doesn't look like a very good 2. There you go, that looks better. -2x minus 8. Okay, y equals -2x minus 8. So if you were to graph those two lines, you would find out that they are actually perpendicular to each other. All right. One line contains the points -4, 2, and 0, 4. The other line has these other 2 points. Are they parallel? Are they perpendicular? Or are they none of the above? This is where all we have to do is just check slope. Just make your decision based on slope. Right here, if you were to go from +2 to -4, you went down by 6. From -4 to 0, you went up by 4. So -6 over 4, which would reduce to -3 over 2. So the first 2 points they give us tell you that the slope is going to be -3 over 2. All right, now we're going to check out the other 2 points, and we are going to make a comparison here. So this one, from -3 to +3, you actually went up by 6, and from -5 to 4, you went up by 9. Rise over run, change in y over change in x, you're going to get 6 over 9, which reduces to 2 over 3. So I want you to compare these two numbers. I want you to compare the -3 over 2 and the +2 over 3. They are not the same number, so they are not parallel. Now, could you flip them and change the sign and make one into the other? If you took -3 over 2 and you flipped it and you changed the sign, would it become +2 over 3? So you would flip it, that would make it 2 over 3. You'd change the sign, that would become positive. Checks out. These two lines are perpendicular. Okay. Last but certainly not least on this lesson. Now they're just going to give you the equations instead, and you have to piece it together. The first example here, pretty easy because the slope is already given to you. You've got a +5 and you've got a +1 over 5. It's a trick question. I always put one in here like this just to fool people. You really want to say it's going to be perpendicular because if you look, 5 and 1 over 5 are reciprocals of each other. You got 5 over 1, you got 1 over 5. They're flipped. But are they opposites? They're both positive, so they can't both be opposites. So as badly as most people want to say perpendicular, the answer to this is neither. These are not parallel or perpendicular. They are none of the above. All right, take a look over here. We'll go to the next problem. We're almost done here. We've got a slope of 3. And then we have another line right here, 9x minus 3y equals 18. I don't know the slope of this line, so I'm going to move things around until it becomes a little more obvious to me. I'm going to subtract 9x from both sides. And then after I get done with that, I'm going to divide both sides by -3. And if I do this, I will officially have slope-intercept form, which is good because when something is written in slope-intercept form, the slope is the first number you see. And it's the easiest way to compare. So I've got y equals 3x plus 1. I've got y equals 3x minus 6. Those two lines have the same slope. They both have a slope of 3, so they are parallel. The only time two lines that have the same slope will not be parallel would be if the two lines are exactly the same line. All right, so obviously we're getting kind of close to our limit here, so I'm going to just cut to the chase. If you were to solve for y in the first example, you would get y equals -3/5 x plus 6. You would have to subtract 3x from both sides and then divide both sides by 5. If you were to try the other one, you would end up getting y equals +5/3 x minus 10. The intercept does not matter. It is all about the slope. And we look at the -3 over 5. we look at the positive 5 over 3. They are flipped versions of each other. They are opposite signs, which means they are perpendicular. All right, I hope this helps steer you in the right direction on the lesson. Have a good one.